Howdy, folks. Excuse me. Let's talk about common terminology in testing so that we are all on the same page. That's where we're going today. Excuse me. I have to get comfy in my weird green chair. This guy. Okay, common terminology. Boom, let's go. Okay, let's try this again. Boom. There we go. So, psychometrics is the field of study concerned with the theory and technique of educational and psychological measurement. Now, this measurement includes the measurement of knowledge, abilities, attitudes, personality trait, essentially anything that people can differ on. So, any individual difference can be measured. Whether it can be measured well is a different question. Now, the field of psychometrics involves two major research tasks. First is the construction of instruments and procedures for measurement. So this is scale development. And this is where new measures are made, previous measures are validated, and the other half of this area is the development and refinement of theoretical and quantitative approaches to measurement. So this is the stat side. This is the side that I do. Archie? Do you mind? Yes. Okay, well, let's keep going. So that's why you have a quantitative psychologist teaching you about tests. Okay, measurement. So in psychology, we are interested in describing the distributions of and relationships among concepts. Archie has discovered the preview screen. Archie, don't you dare. Come on. Really? Sorry, folks. This is just life. So these distributions can be really anything from political conservatism to intelligence, neuroticism, aggression, and even tolerance of cats. We'll see how long that interlude lasts. And yeah, so it's all about describing and linking those relationships. Now, in most cases, these constructs are abstractions that can often not be directly observed. So, for example, the concept of intelligence is this broad idea of being able to figure things out, use information you have, accumulate new information. I'll have a definition by right around here. Now, linking that concept, which is pretty vague and a little tough to describe, to something that we can actually operationalize and measure, like an IQ test, or and these IQ tests can be ranged from like the Otis, which has been around since like 1919, to like military achievement tests. So the Armed Services Vocational Aptitude Battery actually is a measure of intelligence thanks to a congressional mandate that no one be allowed to join the military below a certain ability level. So the core idea that I'm trying to get at is that this process of operationalization is how we linked a concept to a construct. Now, let's give y'all a definition. So, measurement is the assignment of numbers to the characteristics of people or objects. These can range from speed, as measured in like miles per hour, that's actual measurement, to temperature, so Kelvin, order of finishers in a race, so first, second, third, etc., as well as numbers on the back of basketball jerseys. And we can all these different scales of measure can be broken down into two different types of variables. So, and these variables contain the outcome of the measurement process. So qualitative variables are where numbers represent qualities, not quantities. So under Stevens levels of measurement, that would be nominal, where it's just a way to distinguish between, but you can't add up jersey 5 and 7 to get 12. To get 12. You can't add those kinds of numbers together, or subtract them, or divide or multiply, but you can do that with quantities, quantitative numbers. And these levels of measurement range from ordinal, which is just rank order, and those you can't really subtract or add or divide or multiply. But next we have interval, where you can add and subtract. You can't really divide and multiply, but you can at least add and subtract. And last we have ratio, where 0 is actually meaningful, and you are allowed to divide to your heart's content. But backing up, in terms of quantitative, these numbers capture the relationships in the real world. You can apply them. You can actually do some math on them. Now, just to note, so the degree to which the operationalization of an abstract concept actually reflects or mirrors the construct is can be said to be valid. So, and we'll talk a lot more about this later. We got a whole module on it. Now, the value of scientific research is completely dependent upon the degree to which these these drawing of connection, of transforming concepts into constructs are successful or valid. You can have an invalid measure, but a valid concept behind it. So let's do a little more definitions. This is the definition module. So, a concept is an abstraction formed by generalization from particulars. So abstracts are hard to define. They're broad concepts. I just use the definition. So they are broad and capture kind of an ethereal idea. I will put in some examples here, just with some quotes and things, to compare intelligence when it's a concept versus a construct. Now, a construct is a concept with scientific purpose. So it's been operationalized. And that that transformation allows us to measure and study that concept. So as an example, you can think of a construct as any individual difference, personality characteristic, or attribute that we can't directly measure. And so when we're measuring personality traits, we infer it by measuring things that tap into that concept. And for personality, that can be related to thoughts, feelings, or behaviors. So as a measure of extroversion, for example, we could operationalize the broad concept as kind of as a behavior, so talking to others, looking at number of Facebook friends is kind of like a life outcome type measure. Look at informant report data, so that's where you have your peers report about your traits, or self-report, which is the most straightforward, where you just answer the question about if you're extroverted or not. And that's the basic idea. We will crawl so much more deeply into this, but it's a broad overview. So, variables and constants. More definitions. So, a variable is any condition, event, or characteristic or attribute that can take on different values at different times, or with different people. So this could be age, temperature, intelligence, xenophobia, really anything. But it can change as a value. Now, a constant is one value in a given context. It doesn't change or vary. Boom. You likely were exposed to these ideas in your research methods class, but I just want to make sure we are all on the same page. So, independent variables. These can be thought of as predictors. So often we're referring to a variable that an experimenter has some direct control over and can manipulate. So in experiments, IVs are the cause, but in non-experiments, which can still have independent variables, IVs are the influence. So we can't eliminate alternative explanations for the most part in non-experiments, but we can still describe relationships. And typically this is the X variable. It's our predictor. Now, dependent variables, they're the flip. These are the outcome variables that are being influenced or predicted. So in experiments, DVs are being influenced. In non-experiments, DVs are being predicted. This is the Y out of the classic, when you plot them. It's the vertical one. And if you need help remembering this, here's what I do. I think about if I were to fold up the letters, how would I do it? Now for the independent variable, I would smush it down, so the X is smushable, while the Y is, it's more vertical anyway, so it's easier to just, smush it vertically. I don't know why that's how my brain does it, but that's how it does it. Okay, so next, within variables, there are different ways to conceptualize them and measure them. So those scales, those levels of measurement, here we go. So a discrete variable can take on a finite or restricted set of values. For example, it can only take on whole values, number of children in a family, number of students taking intra-level psych, and often the difference between this and the continuous variable is how precise you can get your measure. So a continuous variable can take on an infinite number of values. So think temperature, 10.3 versus 10.24 versus 15.212, etc. Here, it's a level of precision. Cool. Those are hopefully get us all on the same foundation. Cool. I'll see you later. Bye.